Welcome to another 88K model railroad video, and this is an answer back segment where there's a YouTube viewer that had issues with the Hall's effect sensor, and he posed a couple of questions. He couldn't get things going, so this is an answer back, and what we're going to do is we're going to talk about how the Hall's effects work. We're going to talk about the Darlington transistor array. Then I'm going to show you how it's configured. Then we're going to talk about some of the issues with the sensors, and then we're going to do a test operation in Rockrail. So let's get to the bench, and we're going to look at the computer screen at the same time and see what's going on. Okay, so here we are at the computer and at the workbench. We can now go over the board itself. This is the breadboard. We've got the Pico. We see that it's up and running. The slow cadence on the LED shows that it is connected to the Rockrail server. Then we've got the Darlington transistor array, and then we have our LEDs here so we can see some of the indications that occurs with the circuitry. The sensor here is embedded in the track. Then I've got a cold car, and with the cold car there's a magnetic there's a magnet under the cold car itself, and that's what we're going to use to exercise the sensor, the Hall's effect sensor. So we've got power here on the rail. You've got the positive 5 volts. Here's the ground. Then that 5 volt is feeding the sensor, and the negative or positive and negative leads are connected, and then now we have the orange signal lead. To test it out, if we slide the magnet over the sensor, you can see that the LED illuminates, and that shows that the sensor is in operation and that there's a magnetic field above the chip. Here's the issue, and we'll see it shortly. This particular sensor, the way it works is backwards of what we normally like to see a circuit operate. In the idled state, this sensor puts out 5 volts, and in the on state it takes the 5 volts off. So right now this sensor is on, but the 5 volts is removed. So now let's verify that. If we take the 5 volts here, and if we apply it to this LED, we need to apply the 5 volts onto the anode, and then we take the cathode, which is the negative side, and we go to ground. So typically when current flows, the LED illuminates. So now you see that there's no light here on the LED. It's not illuminating. And now let's move the sensor off, or the magnet off, and you see that the LED comes on. So that's an indication that there's 5 volts on this pin. The sensor is providing 5 volts on idle, or when it's off. So let's move this back, and when we move it back, then we see that the voltage or the current is gone, and now the LED is off. This becomes or creates a problem for the Pico, because the way the Pico works is it wants to see a ground. So there's 3 volts that's on the lead, and that 3 volts needs to see, or needs to be switched to ground in order for it to activate the GPIO pin. Let's look at that. So we'll pull this out here, we'll tear this down. What we're going to do is let's swing over and look at the circuit itself. Here we've got the pinouts. You can see that the GPIO 16 is what we're going to use, which is pin 21. That's up in this corner here. And remember, it counts from 1 to 20 and then 21 to 40. And then the GPIOs work around this way. So right here at this point, we're going to see GPIO 16 or IO 7. So here, first, let's supply a ground for the pi Pico, and we see that the ground is on the pin 23, which is third down from the top. So we're going to find the ground. Here's 1, 2, 3, third from the top. This is 20, 21, 20, 21, 22, 23. Let's provide the ground. The pi Pico has a common ground. Let's put in the GPIO pin or jumper. So this is the GPIO pin. It has 3 volts sitting on this pin, and in order for it to conduct, it needs the ground, and once that 3 volts go to ground, then current will flow, and then the sensor, or I'm sorry, the GPIO pin will activate in the pi Pico, and the pi Pico will broadcast that this IO7 is now active or in a 1 state. So let's test that out. So now let's go back to Rockrail. And then also note, before I do that, you can see here, this is GPIO 16, this is IO 7, and then here's pin 23 with the ground. And now this is one portion of the Darlington transistor. And you can see this is in 1 and the out 1. So the GPI is on the out 1 side, and then the input for the sensor, and you see this is the orange lead, is going into the very first position on the Darlington array. So let's go back to Rockrail. Let's look and double check our status on our WIO pi. So here we see that there's ID 40, and we've got 16 incoming, or I'm sorry, 16 block detections. So let's close this and open up the control and go into sensor monitor. So here's sensor monitor, and we see the WIO interface. We see node 40 and now address 1 through 16. And we are specifically looking at 7. So if we apply a ground here, and we can see at address 7, and the state is now 1. And if we remove that, then we can see that it goes to 0. That right there shows us that the ground is what activates the IO pin. It's important to know that this is the way that it functions. There's no other way for it to operate other than going to ground. This sensor lead, orange, the orange sensor lead for the cause effect, is applying 5 volts. The 5 volts will not cause or do anything for the pi Pico because the pi Pico wants to see the ground. So now this is where the Darlington transistor array comes into play. If we set up the Darlington transistor array, and if we go to pin 9, because that pin 9 is the ground, and we apply a ground here, now the Darlington array has a ground, and now it has the ability to route the Raspberry Pi GPIO pin to ground. So now let's put it into the position 1 here, and now let's take the sensor output and put it into position 1. And now remember, the Darlington transistor array, the input is looking for the voltage, looking for voltage. What's going to happen is when the voltage is applied, it's going to act as a switch. Like if you recall, we push the button down, then that's going to cause this to conduct. The pi Pico's 3 volts is going to go to ground. So let's look at the pi Pico, or I'm sorry, at the rock rail. And remember, we're talking about 7. So let's move this sensor 7 and drag and drop it onto our plan, and that way we can close that out. You can see the sensor here. You can see that the sensor is now green. It shows that it's idled. We can see that the orange sensor is in position 1. We've got the cold car that's on the sensor. There is a magnet here causing the sensor to operate. But look at what's happening. You see that it shows that it's idled. It's saying that nothing's there. Let's move this. We're going to remove the magnet off of the sensor. And then as soon as we do that, then look at the sensor. It shows that it's red, which means that it's occupied. So now we can see that the conditions are opposite of what we want. And that's how the Hall's effect sensor works. It's opposite of what we want to see. When it's occupied or covered, then the sensor actually removes the voltage. When it removes the voltage, it opens the circuit. So we can fix that in Rockrail by going in to the properties, and we go to the interface, and now we're looking at node 40, address 7. Here at options, we take it and we go active low. So active low means that it is active when it's 0. So let's apply this. We can close this. Okay, let's go to the sensor, and then now let's reset the counter and then reset the status. Okay, let's move the sensor off, and then now let's move it back. You see that it shows that it's occupied now, and what Rockrail is doing is giving us the opposite conditions. When the cold car is over the sensor with the magnet, it shows occupied, and then when it rolls off, then it shows that it is unoccupied, and it shows the green LEDs. This is the correct way for it to operate, and like I said, it's backwards. Now here's the problem with this configuration. When it's idle, it's actually conducting, or it's consuming current. So it's running when it's idle. So that means that if you have all 16 of these sensors running, then it's going to be on. Everything is on, and it's off only when the sensor is active. And that creates a bit of a problem when it goes in for saturation of power of the equipment, or not the equipment, but the components. Then they could run hot and whatnot. But it's not that much of an issue with these Darlington transistor array. This particular one, which is a ULN 2803A, this one can handle 40 or I think 50 volts. So it's not that big of a deal, but still you want to try to make your circuit run as efficient as possible. The second issue with this sensor is how quickly the sensor will change states, and that's because in this case the magnet is very small. So if you extend the width of the magnet, then you can extend the duration of that on state. So that's something that you have to watch out for. So for the most part, This shows that the Hall sensor can work, but it needs to be able to convert this voltage of 5 volts and 0 to a state where the pi pico can use, and that state or condition is the ground. And that's what the Darlington Array does, is it provides the ground that uses and reacts to the 5 volts from the sensor. It makes the connection, the connectivity goes to ground, and then that's what the pi pico wants to see, and it broadcasts out to the Rockwell server. And because we changed the condition and state for active low, then the right conditions are being displayed in Rockwell. So this pretty much covers it. It answers the question, and now it shows you that the sensors can work, but you have to do a couple of things to tweak it to get it going. So hopefully you guys can use this and get your project going. And as usual, subscribe, like, share, and I'm going to get my notification bell thing going. I have the subscription button set up now so it shows up on all the videos. So once again, thanks a lot, guys. We'll talk to you later. Bye.